Welcome back. So we're going to be writing equations, linear equations from tables. And so there are three ways to represent functions. We've looked at equations, we've looked at graphs, and now we're going to look at tables. So equations for data in tables can be written using slope-intercept form if we know the y-intercept, or point-slope form. Before you write an equation for a linear function, you have to make sure that it's a linear function. So step number one, verify the equation is linear. The slope will be the same regardless of which 2 points are used. So linear functions have a constant rate of change in y over a constant rate of change in x. All right, so in our first table here, that would not be a linear function. We have a constant rate of change in x. It's going up by 1 each time, but we do not have a constant rate of change in y. Right? We go up by 1, then -1, then -3. Right? So that's not a linear function, so we wouldn't write an equation for that one. The second one shown is a linear function. We have a constant rate of change in x, which is 1, and we have a constant rate of change in y, which is -2. Right? So our slope is going to be the rate of change in the change in y over the change in x. So the change in y is -2, change in x is 1, that gives us -2. Or we could use the slope formula. Right, you could use either one if you have a constant rate of change in x. If you don't have a constant rate of change in x, you do have to use the slope formula. Right, so once we have our slope, we're going to identify our y-intercept if it's easy to find. So we're going to use slope-intercept form. Y equals mx plus b if the value of y when x equals 0 is known. It's easy to find. So for instance, here in our linear equation, our second example, because that's the linear equation, there's our y-intercept. Right? So the value of y is -1 when x is 0. So we can just write the equation in slope-intercept form. Y equals -2x minus 1. If we didn't know the y-intercept, then we'll use point-slope form instead. All right, so those are our steps for writing our equations writing equations of linear functions from tables. So let's look at the first one. This one's in your notes, as you can see over there. Always check the x first, because if you have a constant change in x, then you can just use for slope, you can just use change in y over change in x, right? If not, then you'll have to use the slope formula, if it's linear. So here we're going up by 1, up by 1, up by 1, up by 1. Right? So we do have a constant change in x. How about a constant change in y? Right? So we're going up by 2, up by 2, up by 2, up by 2. Right? So each time the next value in the sequence goes up by 2. Right, so this is a linear function. And we know it's a linear function because we have a constant rate of change. That's what tells us it's a linear function. Right, so now we can take the change in y, which is 2, divide that by the change in x, which is 1, which gives us a slope of 2. Here we do know the y-intercept. Right? The value of y when x is 0 is -5. Right? So that means our equation is y equals 2x minus 5. Right? And that's all there is to this problem. Let's look at the next problem. Right? So let's check out our x values. Okay, they're increasing by 1 each time. So the rate of change in x is 1. Let's look at y. Right, so decreasing by 3, decreasing by 3, 2 to -1, decreasing by 3, -1 to -4, decreasing by 3. So this is a linear function. And we know this is a linear function because there is a constant rate of change. Our slope, we can just take the change in y over the change in x. So that's going to be -3 divided by 1, or just -3. And here we are given the y-intercept. The value of y when x is 0 is 2. So the equation in slope-intercept form is going to be y equals negative 3x plus 2. And that's all there is to this problem. Let's look at the next problem. Okay, so let's look at our x values. All right, so increasing by 1, increasing by 1, increasing by 1, increasing by 1. The y values decreasing by 1, decreasing 6 to 5, subtract 1. And, okay, so we do have a constant rate of change, so this is a linear function. And it's linear because we have a constant rate of change. Our slope is the change in y over the change in x. So that's going to be negative 1 divided by 1, or just negative 1. And we do know our y-intercept. The value of y when x is 0 is 6. So our equation is y equals negative x plus 6. You don't have to put the 1 in there. You can just put the negative. Right. On to the next one. Right, so let's take a look at this. Now we don't have a change of 1 in our x's. Right, but let's see. This one is in your notes, but we go up by 3. 5 to 8, we go up by 3. 8 to 11, we go up by 3. 11 to 14, we go up by 3. 14 by 17, we go up by 3. 17 to 20, we go up by 3. So we still have a constant change, which means that if we have a constant change in the y, we can just use that for our slope. Here we're going up by 2, and then we're going up by 4, all right, and then up by 6, and up by 8, and up by 10, and up by 12. So this is not a linear function. So not, actually I'm going to write it over there. So not a linear function. There is not a constant rate of change. All right, so we're not going to write an equation. It's not linear. We can't write a linear equation for something that's not linear, right? So we are done with this particular problem, right? So here we do have a constant rate of change in x, but not in y, so it's not a linear function. Right, so this one is in your notes. Again, this time we don't have a constant rate of change in x or y. Right, so we really can't tell. On this problem here, because I had a constant change in x, we could tell this is not linear because we don't have a constant change of y. If we don't have a constant change in x or y, right, then we can't tell if it's linear unless we use the slope formula. So if there's not a constant change in both x and y, you're going to check the slope between each pair of points. That does mean we're going to be calculating the slope out 1, 2, 3, 4, 5, 6, 7 times. Right? There's 7 pairs. Right? I just go between point to point to point. All right, so our first one is slope 1. All right, so that would be 0.5 minus 2, change in y there, and change in x, 5 minus 2. All right, that's going to give us a negative 1.5 divided by, except I put a 3 in there and not a 2. 5 minus 2 over 3, which is the same as negative 1/2. 1.5 is half of 3. All right, so that's going to be negative 1/2. And let's write this correctly, 5 minus 2. All right, let's find the second slope. All right, so we have a negative 1 minus 0.5 divided by 8 minus 5. So that's, again, negative 1.5 over 3. That's going to be negative 1/2. You do have to check them all. What if I mess you up and I make 1 point different? All right, so then we have negative 2.5 minus a negative 1 is the same as plus 1. So there's a decimal point in there, I don't know if you can see it. Let me write that a little bit nicer. Negative 2.5 plus 1, and then 11 minus 8 is going to give us negative 1.5 divided by 3, and that's a negative 1/2 again. Moving on, we have slope 4, right? And that's going to be -3 minus a -2.5 is plus 2.5 over 12 minus 11. That's going to be a -0.5 over 1. Right? And so that's the same as -0.5 or -1/2. Right? Half is 0.5 is half of 1. Slope 5 is -4 minus a -3 is the same as plus 3. And then 14 minus 12 is going to give us a -1/2. Slope 6, we have -5.5 minus a -4 is the same as plus 4. And then 17 minus 14 is -1.5 over 3, which is -1/2. And the last pair of points, slope 7, -8 minus -5.5 is the same as plus 5.5, divided by 22 minus 17. So -8 plus 5.5 is -2.5, and 22 minus 17 is 5, and 2.5 is half of 5. So that's, again, -1/2. So we clearly have a, there we go. We clearly have a linear function here, right? So this is a linear function. We have a constant rate of change. Right? And we do not have the y-intercept. We could choose any pair of points, any point, or any pair of coordinates that represent a point. I could choose that point, or I could choose this point, or I could choose this point. It doesn't matter. I personally don't really want to choose the ones with the decimals, but it really doesn't matter. So I could make this y minus 2 equals -1/2 x minus 2. Or if I like -1, I can have y plus 1 equals -1/2 x minus 8. Or I could say y plus 3 equals -1/2 x minus 12, and so on. I keep on going, right? I can choose any point. As I was plugging these in, I did simplify those negatives. So it would have been y minus a -1, and I just made it plus 1. Y minus a -3 becomes plus 3. But you can use any point you want. It doesn't matter. And the last one, all right, so let's take a look at this one. All right, so increase by 2 in the x. Always check x first. Plus 2, plus 2, plus 2, plus 2, plus 2. All right, let's see if we have a constant rate of change in the y. Plus 5, plus 5, plus 5, plus 5, plus 5, and plus 5. All right, so this is a linear function. Because we have a constant rate of change. That rate of change is our slope, which is the change in y over the change in x, which is 5 over 2, or 5/2. We don't have the y-intercept. We could choose any point we want. I'll just pick 2, all right? So I'll pick that point there, and let's pick this point here, right? Just to show you could use any point. So y minus 1 equals 5/2 x minus 2, or I could choose y minus 11 equals 5/2 x minus 6, and so forth. I'm going to recircle that one since I'm blocking the number there. There we go. So any point you want here could be from this table could be used to write the equation. Well, I think this is my last problem on this particular podcast. Come back and we'll look at another concept related to linear functions. Thanks for watching. Bye for now.